we now discuss the solution of the problem from the section Differential Calculus. This given question is on the applications of derivatives. This question has appeared in the joint entrance examination main held on 25th June 2022 in the second shift. The given question is, water is being filled at the rate of 1 centimeter cube per second in a right circular conical vessel, vertex downwards, of height 35 centimeters and diameter 14 centimeters. When the height of the water level is 10 centimeters, the rate in centimeters square per second at which the wet conical surface area of the vessel increase is, we are given four options. Option A, 5. Option B, square root of 21 by 5. Option C, root of 26 by 5. Option D, root of 26 by 10. We are given a circular conical vessel whose vertex is downwards, which is of height 35 centimeters and diameter 14 centimeters. And into this conical vessel, water is filled at the rate of 1 centimeter cube per second. Now, when the height of the water level is 10 centimeters, the rate at which the wet conical surface area of the vessel increase is to be computed. That's our given question. We now discuss the solution of the problem in detail. And we have the conical vessel, vertex downwards. The height is 35 centimeters and diameter is 14 centimeters, means radius is 7 cms. So the height is CV 35 centimeters, radius CA is 7 centimeters. Let R, L, V and S be the radius, L this slant height, V the volume, S the surface area of the conical vessel when the height is H. When the height is H, R, L, V and S respectively denote the radius, slant height, volume and surface area of the conical vessel when the height is H. Now, then V is equal to the volume 1/3 pi r square H, yes, and S the surface area is pi r L, where L is the slant height, where L is given by r square plus h square. L square is given by r square plus h square. So S is pi r under the square root of r square plus h square. Given dV by dt is 1 centimeter cube per second. It is from here. Water is being filled at the rate of 1 centimeter cube per second. So dV by dt is 1 centimeter cube per second. Required to find ds by dt, the rate at which the surface area of the vessel increase, that is ds by dt increase, when h is equal to 10. We continue in the next slide. So we have V and S, V is 1/3 pi r square h, S is pi r under the square root of r square plus h square. We are given dV by dt is 1 centimeter cube per second, and dV by dt, to find dV by dt, the relationship between r and h is to be found. Now, in this diagram, triangle CAV is congruent to triangle DBV. Therefore, their corresponding sides are proportional. CA by DB is equal to CV by DV. CA is a radius 7 by DB is R is equal to CV 35 by DV is H. From this, 7 1s are, 7 5s are, so you will get H is equal to 5R. That is the relationship between H and R. Agreed. V is equal to 1/3 pi r square h. In that, substitute H is equal to 5R. Then you will get 5 by 3 pi r cube. Now dV by dt is equal to 1. It is given. dV by dt is 5 by 3 pi into 3r square into dr by dt. 3 cancels, and you will get 5 pi r square dr by dt, that's equal to 1. And we get dr by dt from this 1 by 5 pi r square. Now the surface area S is pi r under the square root of r square plus h square, but we have h is equal to 5r, so we will get pi r under the square root of r square plus pi r 5r whole square, that is 26r square under the square root, that is pi r square multiplied by root of 26. Agreed. Now ds by dt is root 26 pi into the derivative of r square 2r into dr by dt. Now for dr by dt we have 1 by 5 pi r square. Agreed. Pi cancels, r cancels, and you will get 2 under the square root of 26 into 1 by 5r. But 5r is h. Therefore, 2 root 26 into 1 by h. Now, we want to compute ds by dt when h is equal to 10. So, ds by dt when h is equal to 10 is equal to 2 under the square root of 26 into 1 by 10 into 1 by h. h is 10. So, after cancellation, we will get square root of 26 by 5 centimeter square per second. That's what is required in the question. Let's look at our options. Our answer appears against option C. Therefore, the answer for this question is option C. That is the detailed discussion of the solution of the problem on the applications of derivatives from the differential calculus. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.